polarization. So before starting polarization, we should be aware about some terms, specific terms, and then we are going to learn what is the meaning of polarization and like this. So I'm going to start from very simple. Here, here we are talking about the polarization of the light. Light. Now, light is an electromagnetic wave. This is EM wave, electromagnetic wave, and have three mutually perpendicular vectors. E vector, B vector, and K vector. So three mutually perpendicular vectors, E vector, B vector, and K vector. This is electric vector, magnetic vector, and propagation vector. Propagation vector will be in the direction of the propagation of the wave. So here we are having electromagnetic wave. So for example, if electromagnetic wave is like this here, suppose this is x direction, x cap direction. I am assuming this light is traveling like this in the x direction. Suppose light is traveling in x direction, and electric vector, it is in y direction. So what type of electric vector? Electric vector will be something like this. So electric vector of this electromagnetic wave or light will be something like this. So in which direction this electric vector is? It is in y direction. So this is oscillating electric vector, and it is oscillating in the y cap direction. It is oscillating like this. This is electric vector, oscillating electric vector. And perpendicular to this will be B vector. So B vector will be here, this is Z axis, Z axis. So Y cross Z will be X cap direction. So this B vector, it will be in the direction of Z, Z direction you will be. So magnetic vector will be something like this. It will be like this. So this will be magnetic vector here. So magnetic vector is oscillating in the y cap direction. This. Now, this is, I'm
Sir,
saying this is O. Yes, beta, please.
the magnetic field is oscillating in Z cap or Y cap?
Magnetic field is in Z cap. ठीक है?
Z
E
cap.
cross B. What you are aware, you will know that E cross B vector. ठीक है ना? Basically, in this direction, E cross B direction, energy will be propagated by the electromagnetic wave. So this will be the direction of K vector. What it is going to provide you, that will be K cap direction. Now, E vector is in Y cap direction, cross B vector, I'm assuming in Z cap direction. So K vector will be in X cap direction. X cap direction. So electric vector is in Y direction. Magnetic vector I'm choosing here. So this is magnetic vector, B vector here, and here we are having electric vector. So how can you write the electric field here? Electric field E vector, it will be, what is the direction of electric vector? That is Y cap here. Magnitude of the electric vector, I am assuming it is E naught, and this will be sine of omega t. And in which direction it is propagating? It is propagating in x direction. So this will be omega t minus kx. So if you look here, here all the electric vectors, here all the electric vectors of this electromagnetic wave or light wave, they are confined in a plane. ठीक है? In which plane they are confined here? They are confined in the yx plane. ठीक है. So all the electric vectors, they are confined in XY plane. So this type of electromagnetic wave, ठीक है, for which all the electric vectors are confined in a particular plane, that type of electromagnetic wave is called as plane polarized light. ठीक है, that type of light is called as plane polarized light. So the light for which all the electric vectors are confined in a particular plane. For example, here all the electric vectors, they are confined in XY plane. So that type of light is called as plane polarized light. This is known as plane polarized light. So what is plane polarized light? So first condition for a plane polarized light is that all the electric vectors, they should be confined in a particular plane. And what you call this plane? This is called as plane of vibration. So the plane in which all the electric vectors are lying, ठीक है ना, for a plane polarized light, that is called as plane of vibration. Sorry. So you can write here, plane of vibration is the plane. Sorry. Plane of vibration is the plane in which all the electric vectors, all the electric vectors of a plane polarized light are confined. Are confined. ठीक है, this is plane of vibration.
Sir, in which order?
Plane of vibration is the plane. Plane of vibration is the plane in which all the electric vectors, all the electric vectors of a plane polarized light, of a plane polarized light are confined. Are confined. For example, XY plane, XY plane is the plane of vibration here. For example, XY plane is the plane of vibration here. Here. So this is x-axis. I'm assuming this is y-axis. So you are saying that this plane, okay, this is the plane in which this xy plane, this is the plane in which all the electric vectors are confined. So this is plane of vibration. What I call it? Plane of vibration. Now, perpendicular to this plane and intersecting this plane of vibration along the direction of propagation. This is the direction of propagation. This is k vector here. So perpendicular to this plane and intersecting this plane along the k vector. Okay, there will be a plane here. This is z axis here. So if you look at z axis, then you will find out that there is a plane like this. So there is a plane like this. That is intersecting this one. This is. So this type of plane, which is perpendicular, this is, sorry. So this is z axis. So basically, there is a plane that is perpendicular to this plane of vibration. And this plane is intersecting this one, this plane of vibration along the k vector. So where they are intersecting each other, these two planes along the k vector. And what is important here in this plane, that in this plane, along this plane, there are no electric vectors. In this plane, no electric vector is existing. In plane of vibration, all the electric vectors are there, and perpendicular to this plane, there will be a plane like this. There will be a plane like this in which there will be no electric vector. That plane is called as plane of polarization of this plane polarized light. And where these two planes, they are going to intersect each other, they will intersect along the k vector. So this plane, it is called as plane of polarization. Plane of polarization. So plane of polarization, you can write here, plane of polarization is the plane. Plane of polarization is the plane in which no electric vector exists. Plane of polarization is the plane in which no electric vector exists, and it will be perpendicular to plane of vibration. And it will be perpendicular to plane of vibration. And it will be perpendicular to plane of vibration. Full stop. Plane of vibration and plane of polarization. Plane of vibration and plane of polarization intersect each other intersect each other along the k vector along the k vector. So this plane here that is perpendicular to this, that is called as plane of polarization, sorry. So two planes are there. Plane of vibration in which all the electric vectors are existing, and perpendicular to this plane there will be a plane in which no electric vector will be there. That is called as plane of polarization. Okay? So these are two planes which are important here, and you should be aware about these. Okay? Now they will be this plane of polarization and this plane of vibration. It will be widely used during the discussion of polarization. Now, suppose I'm writing a electric vector like this. Electric vector like this. This is some arbitrary direction. I say this is eta cap, and this is E naught sine of omega t minus this will be kx. Then try to understand, this will also be a plane polarized light. This will also be a plane polarized light. Here, in which plane? In which plane all the electric vectors are existing here? I will show you it is propagating here. Try to understand. It is propagating, this wave is propagating in the x direction. It is propagating in the x direction, and this is y direction. We are using right hand system. This is z direction. Okay, so electric vector is not along the y. Electric vector is not along the z. It is making some angle. Try to understand, it is making some angle with respect to y and z. Okay, so you can consider, suppose this is y axis here. Front face I'm showing you. This is suppose y axis and this is z axis. This is z axis. So where your electric vector is, your electric vector is like this. And we are saying this is eta cap direction. Eta cap. Eta cap direction. So in which plane all the electric vectors are? Try to understand your, this is y and z. This will be y and z. So inward. So wave is propagating in the x direction. Inward the board. And what is the electric vector? Electric vector will be here. Try to understand in which direction all the electric vectors will be. Electric vectors will be in this plane. All the electric vectors will be here. So this plane, okay, this plane going inward, all the electric vectors are like this. So this is also a plane polarized light. Try to understand, this is a plane polarized light. What is its amplitude? Its amplitude is E naught. So I can resolve this along this. So one component will be along the z direction, z cap direction. You can write it, suppose this is theta. So I can write it as E naught cos theta. And there will be a component here that will be E naught sine theta. E naught sine theta. Sine theta. So I can resolve this E naught, amplitude E naught along eta cap into two components. One component will be along the z cap, another component will be along the y cap. So how can I write this electric vector? Try to understand. I will write this electric vector in this way. This E vector, it will be, now, this will be E naught. I can take this E naught out. So this will be cos theta here in the z cap direction and sine theta in y cap. So I will write sine theta. This will be j cap plus cos theta component. It is in k cap direction, and E naught is common. E naught is common, and this will be sine of omega t minus kx. So this is also plane polarized light. This is also plane polarized light. Try to understand this is a plane polarized light, because this one, if you look at all the electric vectors, they will be in this plane. From here, how can you find out if this type of form of electric field is given? How you know that this is a plane polarized light? Simple mathematically, I can tell you that its y component. Try to understand its y component is what? Its y component is, this will be E naught sine theta, and it will be sine of omega t minus kz. You can choose z equal to 0 if you want to recognize it. This will be E naught cos theta, and this will also be sine of omega t minus kz. Divide these two. If you divide these two, what you are going to get? You will get Ey by Ez, and that is tan theta. So what is Ey? Ey, and that is tan theta Ez, and this is a equation of a straight line in between Ey and Ez. So this Ey equal to tan theta Ez, this is providing me this line along which all the electric vectors are oscillating. Okay? So this is another form of plane polarized light. So plane polarized light, it's not necessary that all the electric vectors should oscillate along the x-axis, along the y-axis, or along the z-axis. It's not necessary. Whatever plane is there, but in the same plane, all the electric vectors should be confined. So that type of electromagnetic wave is called as plane polarized light. Okay? That type of electromagnetic wave or light wave is called as plane polarized light. Okay? So first thing is this. So this is another way to represent the plane polarized light. How? When we are solving numericals and problems, how you are going to represent plane polarized light? Try to understand. You are going to represent plane polarized light like this. It is propagating in this direction. This is the line along which this plane polarized light is propagating. So its electric vectors may be like this. So these are electric vectors. So here directly you are showing that all the electric vectors, they are perpendicular to the k vector. Okay? K vector. So this is one way to represent plane polarized light. If you are looking from the front side or from the back side, then plane polarized light can be represented like this. So in this plane, wave is propagating inward or outward, and all the electric vectors are confined like this. So this is another way to represent plane polarized light. Here, apart from this, okay, there is another way in which you can, so these are electric vectors. Try to understand, this is electric vector. This is electric vector. So this is K vector and this is E vector. This is also known as plane polarized light. This is also known as plane polarized light. So these are different ways to represent plane polarized light. Another way to understand why I was discussing this case, try to understand from this example that electric vectors, electric vectors of a plane polarized light, they can always be resolved into two mutually perpendicular directions. Here, this was our electric vector. I have resolved this electric vector in this direction and this direction. This direction and this direction. Okay? Try to understand. So a plane polarized light, the electric vector of a plane polarized light, it can always be resolved into two mutually perpendicular components. Okay? And as a result, a single plane polarized light, it can be written as the superposition of these two plane polarized light. Here what I have done, this was a plane polarized light. How you are, here I have resolved this electric vector in two mutually. This is propagating in x direction and this electric vector was somewhere here. Try to understand. So electric vector was somewhere here, somewhere. This is electric vector. So I have resolved this in mutually two perpendicular directions. So these two mutually perpendicular directions, here you can choose one of the direction like this. So wave is propagating in this direction. So electric vector may be in any direction. If they are like this, it is okay. This is the way. If the electric vectors are like this is the way. But if electric vector is making some arbitrary direction, wave is propagating like this, and here direction of electric vector is some direction here. Here some direction like this. Electric vectors are like this. So this is plane polarized light. This is my electric vector. So always remember, okay, I can resolve this into two component. One component that will be perpendicular to this line. So this type of light I'm talking about, this is a plane polarized light. This electric vector is perpendicular to this direction k cap. This is k vector. So this E vector, this is perpendicular to this k vector. I can resolve this into two component. So one component will be parallel to this board. One component may be this. Okay? Another component may be like this. So you can also represent like this. Okay? So you can always resolve this into two components. This is a plane polarized light. So this plane polarized light, its electric vector can be resolved in two mutually perpendicular direction. One will be parallel to the board, another will be perpendicular to the board. Okay? Later on the basis of this, we are going to define what is the meaning of s-polarized light and p-polarized light. What will be the s-polarized light and p-polarized light? We are going to define that. Is it okay here up to this point?
Sir,
Yes, beta.
sir, previous slide, please. I have one doubt.
Okay. Please बताइए.
Sir, here you have done means y into z cap equal to x cap, right? Means it is k cap. So y cap into z cap means here only eta cap is there. So y cap into z cap you are doing?
Mm. Okay, why I'm resolving this into two components?
No, sir, means the direction of propagation, you have done cross product, then it is coming x cap. So it is in eta cap direction. Why? So why you have means resolve it into two component to find the direction of the propagation of.
No, 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 no. I'm not finding from the propagation direction. No. ठीक है, I'm not finding the propagation direction from by resolving it. I'm saying this type of wave I am having. I'm having a plane polarized light like this, whose electric vector is in eta cap direction and it is propagating in x. It is propagating. I'm assuming this type of plane polarized light. I want to show you that it's not necessary that electric vector should be along the y cap direction or z cap direction. It may be in any direction, but that direction should be perpendicular to this x cap. For example, here, so this will be. So electric vector may be in any direction. So this was the direction of electric vector, and I'm saying this is eta cap. So because this electric vector is a vector quantity, I can always resolve into two components. So I can resolve it in two mutually perpendicular direction, whatever direction you are going to choose. So what we will do later on, we will resolve electric vector of a plane polarized light into two components. One component is known as S component, S polarized light. Another will be P polarized light. One will have all the electric vectors parallel to plane of incidence, and another will have all the components, electric vector components perpendicular to plane of incidence. So that's why I am explaining you that you can resolve this electric vector into two components perpendicular to the x cap direction, perpendicular to x cap direction, and these two directions, they will be mutually perpendicular. I'm not saying that by resolving it I'm trying to find out the x cap direction. No, it's not. ठीक है, is it okay
Means
बेटा?
initially eta cap is perpendicular to x cap, right?
Always electric vector will always be perpendicular to k cap. In electromagnetic wave, electric vector will be perpendicular to the k vector. ठीक है, in this direction wave is propagating, so this vector will be perpendicular to x cap direction or k vector. Even here, if you look in this example, here it is propagating in x direction. Electric vector is perpendicular to this propagation vector direction k vector or x cap. ठीक है, here in this case again I am showing you, this is another example of plane polarized light where electric vector is perpendicular to x cap. So eta cap here is perpendicular to k vector. K vector. ठीक है? So basically a single plane polarized light, it can be resolved into two components. You can say that a plane polarized light is the superposition of two mutually perpendicularly polarized lights. ठीक है? It will be a superposition, or it can be written as the superposition of two mutually perpendicular plane polarized light. So after this you can write after this if you want. Please write here, somewhere here. So from here, we can conclude that, a plane polarized light, from here we can conclude that a plane polarized light can be written, can be written, we can conclude that a plane polarized light, a plane polarized light can be written as the superposition of, can be written as the superposition of, as the superposition of two mutually perpendicular plane polarized lights. Two mutually perpendicular plane polarized lights. Two mutually perpendicular plane polarized lights. So this is the way to represent plane polarized light. Okay, during the polarization, we are going to represent. Yes, beta. Hello.
So dot dot is the propagation means it is the parallel means it is dot dot inside the board, right?
Inside the board, electric vectors are like this. Electric vectors are like this means electric vectors, they are confined in a plane that is passing through this line and perpendicular to the board. So all the electric vectors are confined in a plane that is passing through this line and perpendicular to the board. Here, all the electric vectors, they are confined in a plane that is passing through this line and parallel to the board. Okay, all the electric vectors are lying in this board, in the plane of the board. And this plane of the board is also passing through this line. So this is a plane polarized light. This is a plane polarized light. And here, this was my plane polarized light. I have resolved it into two component. One plane polarized light having all the electric vectors parallel to the board, and another plane polarized light that is having all the electric vectors perpendicular to this board. So this is the way to represent any type of plane polarized light. Okay? Next is p polarized light and s polarized light. So this plane polarized light, it can be of two types.
Sir,
Yes, beta, please.
before we, so
Yeah.
any vector in the YZ plane can be considered as plane polarized, right?
No, not any vector, but if all the vectors, ठीक है ना, with electromagnetic wave, electric vectors will be associated. If all the electric vectors, they are confined in a plane, direction may be any. Suppose this is x, ठीक है, in this direction it is propagating, your electric vector may be like this. But all the electric vectors, they should be confined in this plane. Electric vector may be like this. Then all the electric vectors, they may be confined in this plane. Electric vectors may be like this, ठीक है, in this way, ठीक है, in this way. So from here you can look, electric vectors may confine in this plane, then electric vector will be like this. Electric vector confined in this plane.
Yeah.
Electric vectors may confine in this plane, so this will be a plane polarized light. Electric vector may be confined in this plane. So if all the electric vectors, they are confined in the same plane, ठीक है, then it is called as plane polarized light. I'm not saying a particular electric vector in a particular direction. No, if all the electric vectors of that light are confined in a plane, only then this will be plane polarized. Is it okay?
Yeah, just a follow-up question.
Yes.
There is theta, so EY equals to tan theta. So
Yes,
that
but
tan theta will also, limit what all the planes are available.
no, they could try to understand this is x direction. If you are
Yeah.
assuming this is x, this is y, ठीक है? So this is x, y, and this will be z. ठीक है?
Yes.
This will be z. So if this is y, see, just 1 second. If this is y and this is z, like this, so your electric vector, try to understand it should be somewhere. Your electric vector may be parallel to y, like this. Electric vector may be like this, or electric vector will be like this. So if electric vector is like this, then it is going to make some angle with the z or with the x. So whatever
Okay.
angle you are choosing, correspondingly that theta will be. Later on,
Okay.
we will find that particular direction and we will call that direction as the optic axis, or here in case of polarization, we will also call the pass axis. Okay, in case of polarizers. So I will come to that angle also. But it may be you can resolve, you can choose angle theta with respect to y cap direction or z cap direction in this case. Okay?
Okay.
Is it clear? So this may be this theta can have any value. Now suppose, okay, I answer your question in another way also. I will try to find out. Just so this was plane polarized light. Apart from this, there will be unpolarized light also. Unpolarized light. So what will the difference between plane polarized and unpolarized? Try to understand still, because this is light, Because this is light, so electric vector will be still perpendicular to the k vector. So what will be the unpolarized light? Unpolarized light will be like this. This is the k vector. K vector. Yes, beta.
Then the unpolarized light, all the electric vectors are not confined to a same plane, right?
Why? Please repeat your question.
When all electric vectors are not confined to the same plane, it is called unpolarized light.
This is unpolarized light.
Okay.
This will be unpolarized light. So basically, if light is propagating in this direction, then electric vectors surely at every time they will be perpendicular to x cap direction. So now suppose electric vectors are like this. This is a perpendicular direction. Try to understand. If electric vectors are like this is one electric vector. Another electric vector is like this. This will be. So this type of. So if light is like this, which is having electric vector in all possible directions perpendicular to k vector, then that type of light is called as unpolarized light. What do you call it? This is called as unpolarized light. So unpolarized light is having electric vector in all possible directions perpendicular to the k vector. You can write here unpolarized light. An unpolarized light has electric vectors, and unpolarized light has electric vectors in all possible directions. In all possible directions. In all possible directions perpendicular to the k vector. Perpendicular to the k vector. So what can you say about unpolarized light? You can say that unpolarized light, you can say unpolarized light is made of infinite number of plane polarized light. ठीक है. So what is unpolarized light? It is made of infinite number of plane polarized light. ठीक है. Having same k vector, but random distribution of e vector, but random distribution, yeah, rather than but having more simpler, having e vector in all perpendicular directions. Perpendicular directions. ठीक है. So this will be like this. Now try to understand this unpolarized light. It is having so many electric vectors. So you can resolve these electric vectors, all these electric vectors, in two mutually perpendicular directions also. ठीक है. So you can resolve it into two mutually perpendicular directions also. So try to understand. One will be resolved in this direction. One component you can choose in this direction. ठीक है. Another will be like this. Another will be like this. So you are going to resolve a component here. ठीक है. All the components here in this direction, you will call it as EY component. EY, and here in this will be EZ. This will be EY and this will be EZ. ठीक है, this will be EY and EZ. ठीक है, so this is EY and EZ. Now here for this electric vector, these electric vectors will be like this. These electric vectors will be like this. And another component will be here in this direction, so they will be represented like this. So unpolarized light, okay, it can be written as the superposition of two mutually perpendicular plane polarized light. So you can write here an unpolarized light can be written as the superposition of two plane polarized lights. Can be written as the superposition of two plane polarized lights. ठीक है, in earlier case when we were writing, you can a little bit modify here you can write, you was writing here you can write a plane polarized light can be resolved into, yes beta please.
Sir, is there a superposition of two plane polarized light?
Yes, unpolarized light ko, because they are electric vector, direction of propagation is same. Electric vectors are in different directions, so if I resolve all these electric vectors, ठीक है, I can resolve all these electric vectors along this y and z. So here this is the sum of electric vectors in the y direction. This will be the sum of electric vectors in z direction. So you can write this unpolarized light as the superposition of two plane polarized light. One having all the electric vectors in y. Here it is in z. It is in z. Okay? So here,
Okay,
whatever
sir.
I have started here, try to understand what I started from here. Here, a simple plane polarized light was there. Okay, what I have done here, I have resolved this electric vector into two components. So I can write this plane polarized light like this. This is, you can say this is the resolution of this plane polarized light into two components. One component is along the y cap and along z cap. ठीक है, now further we are now again we are moving ahead, and now this time in case of unpolarized light we are having so many electric components, but they are all perpendicular to x direction. So here I can choose any of the two direction. I am choosing one direction parallel to the board, another is perpendicular to the board. So I can resolve all these vectors in two direction, one parallel to the board, another is perpendicular to the board. So I will have this type of electric components. So this is the way to write unpolarized light. So whenever you are writing, this is the way to write unpolarized light. If somewhere is written like this is unpolarized light. This is unpolarized light. So please don't confuse with here. Here, I'm not saying this is, here I was trying to show you electric vectors can be resolved in two components. One is like this, another is like this. One is like this, another is like this. But if you combine these two, you are going to get only this here. Okay? But in this case, try to understand. In this case, okay, so many components are there. So here there will be two plane polarized light. So one plane polarized light here, we are going to call it as P, another is called as S. So, but before that, this is unpolarized light. So wherever unpolarized light is there, unpolarized light is there, it will be like this. You are going to represent it in this way. In this way. Okay? So try to understand this is unpolarized light, and here, this will be here. We are not going to represent plane polarized like this. This is just the direction. Remember that this is, I'm trying to resolve these electric vectors in two mutually perpendicular direction. So this is one of the direction here. This is another direction is here. ठीक है, this will be. So individually if you are writing like this is plane polarized. If this component is there, then this is plane polarized light. If this component is there, this is plane polarized light. ठीक है, and this is. So here it may be this. This is the way. So here I should a little bit modify here, and I should make, so don't be confused with this. Here I'm just telling you how I'm resolving a single electric vector in two components. Later on, when so many electric vectors are there, we have resolved all these electric vectors in two mutually perpendicular directions. Like here, whatever we have done here with one electric component. ठीक है? So we have done the same thing and we find out two plane polarized lights. ठीक है ना? Two plane polarized light. Later on, I will explain you when two mutually perpendicular plane polarized light having a phase difference of 0, when they will be superimposed, they are going to give rise to a plane polarized light, whatever I have done earlier. So this type of light is having electric vector in all possible perpendicular direction to the k vector. They are called as unpolarized light. Okay, this will be unpolarized light. Now, next is p-polarized and s-polarized light. This is p-polarized and s-polarized light and s-polarized. Remember this, both are plane polarized light, s-polarized light. So you have to keep in your mind this is a plane polarized light. This is also a plane polarized light. So both are plane polarized light. ठीक है ना? So both are how? What is the meaning of p-polarized? So before that, we have to understand one thing. If this is an interface, that is separating two medium. First medium is represented by refractive index N1 and second medium is represented by the refractive index N2. So this is an interface between two medium. Now, a light is incident like this. Light is incident like this. Okay? So what will happen here at this interface? A part of this wave will be reflected back in the same medium and a part of it will be transmitted. You call this as reflection, this is called as refraction. Okay? So here this is incident light, this is reflected light, and you call it as transmitted or refracted light. This is called as angle of incidence. You call it as angle of incidence. You call it as angle of reflection. This is also known as, I call it as R prime, and this is angle of refraction. Okay. So what is Snell's law says? One of the Snell's law is actually, or laws of reflection. It says that this n1 multiplied by this angle. So n1 and sine of the angle in the first medium, sine of the angle is I, sine I. It will be equal to the refractive index into second medium n2, and here angle becomes R. So this will be sine R. Okay, so n1 sin I equal to n2 sin R. ठीक है, you call it as Snell's law. ठीक है, this is one of the laws of refraction. Another one is that this k vector of incident light, k vector of this reflected light, kr. ठीक है, and this is normal at the point of incidence. What is this? This is point of incidence. This is normal. ठीक है, normal to the interface at the point of incidence. And this k vector of the refracted or transmitted light, all the three k vectors and this normal, they will all lie in the same plane. They will all lie in the same plane, and that plane is called as plane of incidence. What you call this plane? You call this plane as plane of incidence. So, all the three, you can say, all the three k vectors, all the three k vectors, k vectors means ki vector, kr vector, kt vector, and normal to the interface, and normal to the interface, normal to the interface at the point of incidence, at the point of incidence, lie in the same plane, in the same plane. And what this plane is called, you call this plane as plane of incidence. So this is called as plane of incidence. What do you call? You call this as plane of incidence. So this plane, same plane, what I'm saying, this is called as plane of incidence. Okay? Now, on the basis of plane of incidence, on the basis of plane of incidence, plane of incidence, plane polarized light can be classified into two categories. Into two categories. Number one, p-polarized, and another is s-polarized light. S-polarized. Okay? P-polarized and s-polarized. Okay? So what is the meaning of p-polarized first? Okay? So on the basis of this plane of incidence, if light is incident like this, it is reflected, it is transmitted, then this plane in which all the three k vectors and this normal lies. Okay? This is called as plane of incidence. This is called as plane of incidence. Now first p-polarized. First is p-polarized light. So this was interface. A light was incident like this. A part of it will be reflected back. This is reflected light. A part it is going to be transmitted here. So I'm saying this is I. I'm calling this is I and this is R. R. They are like this. Now if electric vector, this is a plane polarized light. This is a plane polarized light. And what type of plane polarized light? Where its electric vectors are? Its electric vectors, all the electric vectors of this plane polarized light, they are like this. They are parallel to plane of incidence. Try to understand. All the electric vectors. For the reflected light, electric vectors will be like this. For the transmitted, electric vectors will be like this. So you can write a plane polarized light is a plane, please write P polarized light is a plane polarized light. P polarized light is a plane polarized light, whose all the electric vectors, yeah, whose electric vectors are parallel to plane of incidence. Whose electric vectors are parallel to plane of incidence. Plane of incidence. Whose electric vectors are parallel to plane of incidence. So this type of plane polarized light, this is called as p-polarized. This is called as p-polarized. Is it okay, beta, up to this point? There is one important property, ठीक है, which you study in your electromagnetic course, ठीक है. Property is if this angle of incidence, this if angle of incidence I is equal to polarization angle, ठीक है, is equal to theta p, ठीक है, polarization angle. What is this? Polarization angle. What is theta p? Theta p is how much? That is tan inverse n2 upon n1. This is n1, first medium from which light is incident, second medium into which light is entering, light is transmitted. So theta p is tan inverse n2 by n1. So if angle of incidence is equal to theta p, polarization angle, you also call it as Brewster angle. Brewster's angle. Brewster's angle. Then what happened in this case? If this is theta p, then what you find out, there is no reflected light. When this plane polarized light is incident at this Brewster angle or this polarization angle, what you are going to find out, there is only this transmitted part. Means for the plane polarized light, there is a particular angle theta p at which reflected part will be absent. Or you can say that reflectivity here, capital R, that becomes 0. This is the property of this p-polarized light. You have to remember this. Okay? Please remember this. This is. So here, no reflected light. Here you can say no reflected light. Light will be there. Okay? So here, there is a particular angle, ठीक है ना, theta p, it at which if this p-polarized light is incident, then there will be no reflected light, only transmitted light will be there, only refracted light will be there. ठीक है, so this is the case. This type of light, plane polarized light, this is called as p-polarized. This is known as p-polarized light. Next is, please note it down quickly. This is known as p-polarized light. Next is s-polarized light. Next is s-polarized light. S-polarized light. So here, this is the interface between two medium N1 and N2. Light is incident like this. This is normal. So a part of it will be reflected back. A part of it will be transmitted. You call this angle as R, and here this is angle of incidence. It is like this. Now suppose this is plane polarized light. What is this? This is a plane polarized light whose electric vectors are like this. They are perpendicular to the board. It is having electric vector, all its vectors like this. For this incident light, they are confined in this plane, perpendicular to this board, perpendicular to this board. For this reflected light also, all these electric vectors, they will be confined in this plane. So this will be plane polarized light. But all the electric vectors, they are perpendicular to the board in the transmitted also. So this type of plane polarized light whose electric vectors are perpendicular to the plane of incidence. Okay, so here electric vectors are E vector are perpendicular to the plane of incidence. Plane of incidence. So you can write S-polarized light is a plane polarized light. S-polarized light is a plane polarized light. S-polarized light is a plane polarized light whose electric vectors are perpendicular to the plane of incidence. Whose electric vectors are perpendicular to the plane of incidence. Whose electric vectors are perpendicular to the plane of incidence. Now, another important property of this is, so this was plane of incidence and you are having S-polarized light. So what we are having, we have launched this S-polarized light. This is plane polarized light, S-polarized type, this type of light. So, and it is launched at the same angle theta p. It is also launched at the Brewster angle. This is N1, N2. It is also launched at angle of incidence here is equal to polarization angle. Then what you will find out in this case, if S polarized light is there, then in this case, reflected part will be present. So there will be reflected part. There will also be transmitted part. So this is R. So this is S polarized light. So these are P polarized and S polarized light. Now, on the basis of this understanding, now we can understand or we can learn how to produce plane polarized light. Next question is how to produce plane polarized light. So plane polarized light can be produced in many ways, but we are here, we will discuss those methods which are important for your exam, on which questions can be designed. One is polarization by reflection. And here Malus law will be there, and questions on Malus law may be in the exam. Okay, next will be that is important for us, that is by double refraction. So we will also discuss the double refraction and how plane polarized light can be produced with the help of double refraction also. So in the next class, I will start from here. I will discuss how to produce plane polarized light, what is Malus law, how to handle the questions of related to that part, Malus law and this polarization by the reflection. That is very important for your exam. Okay?
Sir,
Okay, beta. Yes, beta, please.
sir, please first slide and second slide once.
Okay, I will show you all the slides. Please save all these slides. So this is the first one.
Uh,
Yes, beta.
in S-polarized light, The
Yeah,
incident light is reflected and also transmitted, right?
please repeat your question.
For any light, that incident on a plane will get reflected and also get transmitted, right?
Yes. Okay.
Then
There may
what's
be
so
there
special
may
in
be TIR
polarization?
also. In that case, transmitted part will become zero. In case of TIR, transmitted part may become zero. Yes, beta, please.
Then in s-polarized light, when incident at polarization angle, this also get transmitted and reflected. What is the difference between both two?
In case of p-polarized light, ठीक है, first difference between these two are their electric vectors. First difference is in case of p-polarized light, all the electric vectors, they are parallel to the plane of incidence. In case of s-polarized light, all the electric vectors are perpendicular to the plane of incidence. This is the first difference. Second, that I'm going to use later on, one observation is that if p-polarized light is incident at the polarization angle, if angle of incidence is polarization angle or Brewster angle, in that case, reflected part, there will be no reflected part. You are not going to get reflected light. ठीक है, only transmitted light will be there. ठीक है, and in case of s polarized, you will find out that both the components are there. ठीक है, why it is happening? ठीक है, how you find out this angle? Basically, that you are going to study in your electromagnetic course. There is a chapter related to electromagnetic waves in which you are going to discuss reflection and transmission of electromagnetic waves. You will find out Fresnel's formulas. ठीक है, with the help of those Fresnel's formulas you can find out, ठीक है, in at which angle for p polarized light, ठीक है, reflected light or reflectivity, that will become zero. R will become zero, and from there you find out this angle, and it can be verified experimentally also. ठीक है, so
So in all the cases, why are we considering only electric vectors?
because for polarization, ठीक है, in polarization electric vectors are used. ठीक है, not magnetic vector. They are not playing a role here. Magnetic vector comes into the picture later on. ठीक है, if intensity of the light is going to increase. Here we are considering light of normal intensities. ठीक है, so but if intensity of the light, like laser light, when it becomes very large, then you will find out this B vector starts playing its role also. ठीक है, in that case this B vector also comes into the picture, but here this B vector doesn't play a role in case of polarization. Only electric vector is playing the role in case of polarization. ठीक है, I will try to answer this question, ठीक है, in the next class also when I will further discuss. ठीक है, a little bit more. ठीक है, but your answer, you can understand this answer of this question when you are going to deal with lights or laser lights whose intensity is very large. And when you start decreasing the intensity of the light, you will find out B vector is not playing any role at this level, at these intensities at which we are playing here. So this is the first slide, beta. Save it. This is the second one.
Sir,
Yes, beta.
this red color plane is plane of polarization, right? Means it
Yes,
will.
this is plane of polarization in which no electric vector is there. Here, this is plane of vibration in which all the electric vibrations are there. So they are mutually perpendicular. If you look at this, this is XY plane and this is XZ plane. They are intersecting here. Both these planes, they are intersecting along the same line. They are perpendicular to each other. So this red plane is plane of polarization, and this black one, this is plane of vibration. This is the
Sir,
second. Yes, beta.
sir, I have doubt in one line. Can you explain it? A plane polarized light can be written as a superposition of two mutually perpendicular plane polarized lights. Sir, once again, please explain it. I can't. Means I have a doubt. Network problem is there.
What should I explain? Please repeat your
A
question again.
plane polarized light can be written as a superposition of two mutually perpendicular plane polarized lights.
Okay. You can do the reverse of this. ठीक है ना? You can think in the reverse way. Actually, I was explaining that part because later on I am going to use it. But you can reverse it. Your question. If you are having two mutually perpendicular plane polarized light, in between which phase difference is 0 or 2 pi or 4 pi, then ठीक है ना, together, ठीक है, by the superposition of these two you are going to get a plane polarized light again. ठीक है, I will prove it, beta. So for today I'm not going to further explain, but I will answer this question because this is a part on the basis of which double refraction, ठीक है ना, can be explained. So when I will explain further in double refraction, you will understand what I am saying here. But just in simple way, I can show you one thing here. Actually, this eta vector, it is an arbitrary direction. Eta vector is perpendicular to the x direction. This is x cap direction, and it is perpendicular to this. Okay, it is perpendicular. This eta cap is any arbitrary direction, not y or z. I'm not choosing arbitrary. So I can resolve this eta cap into two components, one parallel to y, one parallel to z component. So automatically this E naught eta cap, what will be this eta cap? Eta cap will become, this is the unit vector in this direction. So this, what is this eta cap? This is the unit vector in this direction. This is unit vector in this direction, eta cap. How can you write this unit vector in this way? By this method here. Okay, eta cap resolved in this direction, it will have cos theta. Eta cap resolved in this direction, this will have sine theta. E naught is multiplied here, so this will be E naught cos theta, E naught sine theta. So this, I have resolved this eta cap unit vector into two directions. So this of the equation I can write like this. Now, what type of equation is this? This is, you can consider it like this. This is, you can write it as j cap Ey plus k cap Ez. So here you can write E vector like this. So individually, if you look at this, if only this type of plane polarized light is there. So if you forget this, this will be a plane polarized light whose the electric vectors will be in the y direction. If you forget this, this will be a plane polarized light whose electric vectors will be in the z direction. Now, if you combine, superpose these two, you are going to get this one, this one. But what is important here, that they are having same phases. Phase difference between these two, that is 0. That is important. If phase change, if there is some phase difference like 45 degree, or it may be 60 degree, it may be 80 degree, then things will change. Phases should be same. Okay? Phases. That's why I am saying that a plane polarized light, ठीक है ना? You can obtain a plane polarized light by the superposition of two mutually perpendicular plane polarized light, in between which phase difference is zero. So I'm writing like this. So this is just by simple mathematical
There
calculation I
will
have
be
shown
phase
you.
difference, then it will be unpolarized, right?
Pardon? If?
If there is a phase difference, then it will become unpolarized, right?
No, it's not necessary it will be unpolarized. It may become circularly polarized. It may be elliptically polarized. So there will be different cases. Okay? If I introduce here some phi and I start changing that, then you will find out different type of polarization. Okay? If phi is equal to 0, you are getting plane polarized. If you are changing phi, you may get elliptically polarized. You may get circularly polarized also. I will come to that. But not unpolarized. ठीक है ना? But not unpolarized. So I'm showing you all the slides here. This is first one. Second one. Third one. Fourth. fifth, sixth, seven, 8. Okay, beta. Thank you very much.
Thank you, sir.
Welcome, beta. Good night.